Morning class. Today we're going to continue on factoring trinomials, but we're going to look at um, different situations where they don't have any perfect squares, and then we're gonna look at how to factor cubic sums and differences. Cubic are terms or variables that have the third power, so we call them cubic. If you think about volume, volume has three dimensions, right? And when you would look at a three-dimensional cube, it has length, width, and height. So that's where the term cubic comes from, to the power of 3. So let's scroll down here and see what we're going to learn today. So it says in the last lesson we learned how to factor trinomials that are not perfect squares. All the trinomials had a leading coefficient of 1. Today we're going to look at how to factor trinomials that have a leading coefficient that is not equal to 1. We're going to be using a method called bottoms up. Okay, so this is saying that if the leading coefficient is another way of saying this letter A in the front. Let me color it purple. So let me underline this part. Leading coefficient. So when I'm saying that we're going to check to see if the leading coefficient is 1 or not equal to 1, we're going to look at situations where it's not equal to 1. And in the bottoms up method, it says that first we need to multiply the leading term and the last term. So we're multiplying A times C, and we're going to write that multiplication in the table. I usually write it up here or in the place of this. And then B is the term in the middle, and so we're looking for two numbers that multiply to give me A times C and two that add to give me B. So it's very similar to what we were doing last time. The only difference is that instead of having a 1 in front, we have a number that's different than 1. And then the third step, let me zoom out here. Okay, the third step is we're going to set up two parentheses. Here I put X, but it can the letter can change depending on the problem, because the problem is going to have it could have Y, it could have M, it could have R. So the variable, the letter can change. But here I just put X, but we can put any letter depending on the problem as it changes. And it's plus or minus, depending on what worked in the table that we made. And then there's an extra step that we didn't do before, right? So up to step 3, that's what we did before. Step 4 is where the bottoms up method happens. So let me scroll down to step 4. Okay. So step 4 says divide the constants by a factor of A. Remember, A was the leading coefficient. It's leading coefficient. If you get a fraction, reduce the fraction. If your constant is an integer, then you write your answer. If a constant is a fraction, then you bring the denominator up. Hence the bottoms up as the numerical coefficient of the leading variable. Okay, so there's a lot said here, but it makes sense once we start working on an example. So let's go over to the example. Okay, so this 10 in the front is my leading coefficient. So the leading coefficient is this number in front. Okay. But we're going to make a table So let's make this table here. And what do we notice about this leading coefficient? Is it 1 or bigger than 1 or different than 1? Right? It's 10. So because it's different than 1, we're going to use the bottoms up method. So check when you're starting off a problem, check what's the letter at the very front. You know, if I set them up in standard form from greatest to smallest, what's my leading number here? Okay, so we're going to make a table. On the left side, we're going to look for two numbers that multiply, and on the right side, we're going to look at two numbers that add. We're looking for two numbers that add to give me 9, and two numbers that multiply to give me, what is 10 times 2? It's 20. Okay, so we have our table set up. So again, we're looking for two numbers that multiply to give me 20, and then that they add to give me 9. Okay, so we can think of the different multiplications of 20. That's 1 times 20. But 1 plus 20 is 21. No, that doesn't work. Get a different color here. So this one works, but this one does not. Okay, so let's try another multiplication. I could do 2 times 10. That gives me 20. Check, right? But 2 plus 10 is 12. So that doesn't work. I want to get a 9, right? So what else? 2 times 20. 4 times 5 is also 20. And what's 4 plus 5? Does that give me 9? Yes. So I have 4 and 5 work out. 4 and 5 multiply to give me 20, and 4 and 5 add to give me 9. So this is going to be equal to, set up my parentheses. What's the variable? It's a, right? So I'm going to put a, and then the numbers that worked. So the numbers that worked were positive 4 and positive 5. So positive 4, positive 5. But be careful, because we're not done yet, right? We need to work with the leading coefficient. So come back and remember, was there a number in front? That number in front is the leading coefficient. So the leading coefficient is 10. Let me color it in purple. The leading coefficient is 10. We need to divide the 4 and the 5 by 10. We need to divide, let me zoom out a little bit. We need to divide the 4 and the 5 by 10. And then the next step says, okay, after you divide the 4 and the 5 by 10, can you reduce the fractions? What's 4 divided by 10? Can I reduce it? Is there a number that can divide both of them? They're both divisible by 2. So 4 divided by 2 is 2. 10 divided by 2 is 5. And then reduce the second fraction, 5 over 10. Both 5 and 10 can be divided by 5. 5 divided by 5 is 1, and 10 divided by 5 is 2. Okay. And then comes the bottoms up method. Since we ended up with fractions, those fractions have denominators. And what we're going to do is, after we reduced the fractions into smaller ones, we're going to move the denominators to the front of each variable here. So the resulting parentheses is going to be 5a plus 2 and 2a plus 1. Because notice I moved the 5 to the front of a, so it's going to be 5a plus the 2 stayed there. Then I'm going to move this 2 in front of a, so it's going to give me 2a plus the 1 stayed, so the 1 comes down. So that is my final answer. And you can write it up here. Okay. That's essentially the bottoms up method. So again, what did we do, right? To recap, we set up, we checked to see if the first number is 1 or something different than 1. Since it was 10, that means we're going to have to use the bottoms up method, but we still have to create a table. Then we multiply the first and the last number to get the multiplication for the table. And then we use the middle number to get the addition. And so we're looking for 2 numbers that multiply to give me 20 and 2 numbers to add to give me 9. We found what those numbers are. It's 4 and 5. Then we make sure not to forget about the leading coefficient. It was 10. So we need to take this number and divide the 4 and the 5 by that 10. Then we reduced the fraction. And then if we reduced it and we still have a fraction, we take the denominator, move it to the front, and that is our answer. Okay, so let's practice it again. We have 2 more times to practice it. Okay, the next one. So the leading coefficient here is 4. Okay, so we're going to make our table. And we're looking to multiply, oh, sorry, wrong color. We're looking to multiply the first and the last. So 4 times 7 is 28, but let me color it in red. 4 times 7 is 28. And then the number in the middle is negative 16, so we're looking to add to get 16. Okay, so the multiplications of 28. It's 1 times 28, 4 times 7, and 2 times 14. And let's try, for example, 2 times 14. 2 times 14 is 28. What's 2 plus 14? That's 16. So that the 2 times 14 checks off the multiplication, right? I get 28. But do I want to get positive 16 or negative 16? I want to get negative 16. So that doesn't work for the addition part. How can I change that positive 16 to negative? Right? Well, I know that the 2 and the 14 need to add, but they need to add negatively. So what about what's negative 2 times negative 14? Well, that's still positive 28, because a negative times a negative is positive. But then what happens when I add these two negatives? What's negative 2 plus negative 14? That's negative 16. So we have check mark on both sides. So that means I can set up my parentheses. What's the variable here? X, right? So X and X. And what are the numbers that worked? I was negative 2 and negative 14. But don't forget the leading coefficient. It was 4. So we need to divide both the numbers that we got by 4. And then reduce the fraction. This is x minus 1/2. Right? Both 2 and 4 are divisible by 2. 2 divided by 2 is 1. And 4 divided by 2 is 2. And then looking at the second one, both 14 and 4 are both divisible by 2. 14 divided by 2 is 7. And 4 divided by 2 is 2. And so I'm left with fractions, and so I have to move these bottom numbers up to the front. So I'm going to end up with 2x minus 1 and 2x minus 7. Right. Let's look at example 3. Okay, so for this one, let's see. Okay, so the leading term is 2. Leading coefficient is 2. Then I need to set up the table. So I'm looking to multiply 2 and negative 12. That gives me negative 24. And the middle term is a positive 5, and I need to add to give me that positive 5. So two numbers that multiply to give me 24 and add to give me 5. We can try 8 times negative 3. That's going to give me negative 24. So that checks off. And then what's 8 plus negative 3? That's positive 5. So that checks off too. So what's the letter? I could set up my parentheses, but the variable is going to be m and m. And the numbers that worked were positive 8 and negative 3. Don't forget about the leading term. The leading coefficient is a 2. So we're going to divide both of these by 2 and then check to see, can I reduce? So what's 8 divided by 2? It's a whole number, right? 4. But then can I reduce 3/2? No, right? So it's going to stay as a fraction. But then we do the bottoms up method. Right? Since there is no denominator on 4, we don't have to do the bottoms up. Even if we did, if we said it was 4 divided by 1, then I would move the 1 in front of the m, but 1 times m is m, right? So in this case, we're only going to do the bottoms up on the second parentheses. So the first parentheses stays the same. I just copy it and bring it down. But the second parentheses, I'm going to put the 2 in front of the m, and then subtract the 3. And that's my answer there. So it's m plus 4, 2m minus 3. All right. So now we're going to look at factoring cubic sums and differences. We're going to look at how to factor cubic sums and differences. Before we can get into the process of factoring cubic sums and differences, we need to generate a list of perfect cubes. And so here we have below a list of perfect cubes. Okay, so 1 is a perfect cube because we would say the cube root of 1 is a whole number, 1. Which means that to check it, we could say, if I raise this 1 to the power of 3, does it give me back the perfect cube? Yes. So let's look at another value on the table. So here in this table it says that 8 is a perfect cube because the cube root of 8 is 2. We can check that. If I take the 2 that I got here, what's 2 to the power of 3? 2 times 2 times 2 is 8. Is 8, so is that the perfect cube that I started with? Yes. So this is just a list of numbers that can do that. You know, you have 64. I think maybe the highest that we'll see is maybe 125, maybe 64, maybe 125, for sure 64 and below. And then you have the negative versions. You know, if I have a negative 8, that's also a perfect cube. So that when I take the cube root of negative 8, it's equal to negative 2. And we can check this cube root operation by going backwards and saying, what's negative 2 to the power of 3? Right, that's negative times negative times negative. That's going to end up with a negative, and 2 times 2 times 2 is 8. Okay, so let's go ahead and look at the next page. The next page is kind of a formulation, you know, just like factoring special products, you know, it had patterns. Cubic sums and cubic differences also have patterns. Okay, so a cubic sum has the following pattern, but we can remember this pattern by just looking at the acronym SOAP. Yeah, let me zoom out a little bit over here. Okay, that looks better. All right, so here we have a cubic sum and a cubic difference. It's called cubic because they're raised to the power of 3. You have a value or a variable that's raised to the power of 3, raised to the power of 3. And it's called a sum and a difference. Sum is because it's adding on one, it's adding 2 cubes, and the difference is subtracting 2 cubes. And so when you're adding or subtracting cubes, they can be factored into the following format. And there's an acronym that helps correspond these two formats. Okay, so if I'm going from the left to the right and I want to factor, I know that it's going to be made up of 2 parentheses, like we've been doing. We keep setting up these 2 parentheses. On the first parentheses, we're going to have A plus B. So the S stands for the same sign. So if the problem has a plus in the middle, then the first parentheses is going to have a plus in the middle. If the original problem has a minus in the middle, then when I set up my two parentheses, the first parentheses is going to have a minus in the middle. Okay, so that's what it's talking about in red, the same sign. The blue part is saying it's going to have an opposite sign. Okay, then when I'm working on the second parentheses, if the problem started with a plus in the middle, then the second parentheses is going to start with a minus. If the original problem had a minus in the middle, then the second parentheses is going to have a plus in the beginning. So that's what it means by opposite sign. And then the last thing, the AP, always positive. In the second parentheses, in the last term is always positive. Okay, so it's same, opposite, always positive. Okay, and I'm gonna zoom out so that it can stay within our window. Let me check to see if it does. Just for this first example. Yes, okay, perfect. Okay, so we can be able to see, yes, we can be able to see the formulation over here and the problem over here. So here I have x to the power of 3 plus 8. So x to the power of 3, can I take the cube root of that? So what is the cube root of x to the power of 3? Well, the cube root and the cube, the power of 3 and the root, will cancel each other out. So that's going to leave me with x. The next question is, can I take the cube root of 8? Well, if you look at in your notes the cube table, what's the cube root of 8? What number multiplied by itself 3 times will give me 8? So that's 2. Okay, so this x and this 2 are going to be like my A and my B. But let me use a different color instead of blue. So, but I need to erase it, so let me put back the x there. Let me choose a different color. Choose orange. Okay, so this is going to be my A. This is going to be my B. Okay. So now we see in our formula here, right? We see A to the third, B to the third. So now what we're going to set up is the two parentheses. So we have equals equals, parentheses, parentheses, and then a larger parentheses. So notice that my first parenthesis is small, or the space in my first parentheses is small, and the space in the second one is bigger because I'm going to write more in the second one, right? So we're going to use SOAPs. Same, opposite, always positive. Same, opposite, always positive. So in my first parentheses, it's going to be, picking the colors here, making sure I have them ready. Okay, in my first parentheses, if the middle sign is positive, then this one is also going to be positive. And then I'm going to put A. A plus B. And then it's going to be a squared, but then the sign after a squared is going to be opposite to the middle middle term. So if the middle was plus, then there's going to be a minus here, minus a times b, and then plus b squared. And so this is my SOAPs. It's same sign in the first parentheses. Then if the middle was plus, then I'm going to have a minus in the second parentheses. And then the last sign is always positive. Okay, but now let's plug in everything, right? Instead of a and b, I'm going to plug in x and 2. So my answer is going to equal to x plus 2x squared minus, what's, instead of a times b, what's x times 2? It's 2x plus, what's 2 squared? What's b squared? That's 2 squared. What's 2 times 2? It's 4. So this is my answer here. All right. So let's try it again. But this time we're going to do the minus version. So now we have a minus here. And so I can ask the same question again. Since I have something to the power of 3 minus something to the power of 3, will the 64 have a cube root? We can check the cube root table. Is the 64 have a cube root? Yes, it should be 4, right? Does 27 have a cube root? Yes, it should be 3. And y cubed is also a cube. So we have a cubic difference here, subtraction. But just to write it down, right, we're going to say the cube root of 64y to the third is equal to 4y. And then the cube root of 27 is equal to 3. So this is like, again, my A, B. So I'm going to equal it to, set up my 2 parentheses. It's going to be A, B. Remember, same, opposite, always positive. Let me see. So I'm just going to copy all the letters. So it's AB, A squared, AB, B squared. So AB, A squared, AB, B squared. But then we have to fill in everything in between them, right? There used to be a sign here, a sign here, and a sign here. So 1, 2, 3. So it's going to be same, opposite, always positive. So the last one is always positive. The first one is the same as the problem. So if the problem had a minus, then the first parentheses, first space is going to have a minus. And then the one in the middle is going to be opposite. So if the middle was a minus, then this space is going to be a plus. All right, and so then let's fill it in with A and B over here. Equal to 4y minus 3 what's 4y times 4y? 4 times 4 is 16, and y times y is y squared, plus a times b. A times b. What's 4y times 3? 4 times 3 is 12, so that's 12y plus b squared. 3 times 3, that's 9. All right, so we've practiced it in example 4 with the plus situation. We practiced it in example 5 with the minus situation. So let's see. Let's try example 6, but without having to look at the steps or the rules. Okay, so let's try it out. So first step is checking to see if I can do the cube root, and also identifying, that there's a plus in the middle. The cube root of 125 is 5, and the cube root of z to the third is z. So this is my a, and my b. It's going to equal to 1 parentheses and then another parentheses over here. So it's a b, a squared, a b, b squared. And the signs are going to be the same as the problem, plus, plus. Then it's going to be opposite. And then always positive. Okay, so in the next step I'm going to substitute. So my a is 5 plus z. Then it's going to be 5 squared. 5 times 5 is 25, minus 5 times z is 5z, plus z squared. Now you can rewrite these. You can do one more step and you can say, like in the first parentheses, can I switch these? Instead of saying 5 plus z, can I put z plus 5? Yeah. And in the second parentheses, can I organize this into standard form? Can I put this one first, this one second, and this one third? Yeah. See, positive z squared is going to be first, minus 5z is going to be second, and positive 25 is going to be last. This is my final answer. All right. Well, thank you for joining me. If you have any questions, we'll be going over it in class. And have a great rest of your day.